So this is problem 25, chapter 4, Giancoli 6th edition. So we have two buckets, they both have the same mass, and they are hanging from a massless cord. Okay, so here I have my lower bucket. This is a cord, attaching it to a second bucket, and then another cord, and they are hanging from the ceiling. Okay, and then comes the questions from the problem. The first question is, if these buckets are at rest, so if there is no acceleration, so acceleration is 0, what are the tensions in this cord? No, the tension in the lower cord and the tension is the upper cord. So to solve the problem, let's write all the forces acting on each bucket. Okay, so starting from the lower bucket, I have mg, which is the weight. How about the top one? I also have mg. Okay, now focusing on the bottom one, what we have is this bottom one try to pull the top one. Okay, so there is here through the rope, it tries to pull it down, so I'll call it the tension between the buckets. Okay. This bucket, the top bucket, react and try to pull it up. Okay. So these two forces have the same magnitude, opposite direction. Very well. Now let's go to the top bucket. In addition to these two forces that we marked here, this box here also tries to pull the ceiling down. So I have here the tension caused between the bucket and the ceiling, while the ceiling reacts and tries to bring it up. Okay. All right, so action and reaction, and we have all the drawings for all the forces. So let's try now to write the equations for each one of these buckets. So the lower bucket. For the lower bucket, what are the forces that we have? Well, let's choose a reference frame now. So I'm going to choose up being positive. Okay, so mg is pointing down, it's going to be minus. What else do I have? The tension force between the buckets, positive because it's pointing up. These are all the forces on the lower bucket, and there is no acceleration. We already said they are at rest, so this is equal to 0. Let's go to the upper bucket. For the upper one, what do we have? Well, pointing down, we have mg. Also pointing down, we have the tension between the buckets. Okay? And pointing up, we only have the tension between the bucket, the top bucket, and the ceiling. And this is equal to 0 because they are at rest. Okay? So from the equation here at the bottom, I can get the tension force of the bucket. And so from here I can get the tension force in the lower. So this is the tension force in the lower cord. Okay. Once I get this, I put it up, and now I can get the tension force on the upper cord. Okay. So we are done. Okay, now comes part B. What is going to change in part B? We now have an acceleration. Okay, so in part B, we have an acceleration up. So it's a positive acceleration. So this is what we have to include now in our equations. So everything here remains the same, except that instead of 0, I'll have plus ma. What is this m? The mass of the upper bucket. At the bottom, what are we going to have? Everything is the same. What changes is that I have here plus ma. What is this mass? The mass of the lower bucket. So they give us the value of this acceleration. And so now it's just a matter of solving these equations. Again, I will find the tension force for the lower cord, now using mg and ma. Once I get that, I go up here, and now I'll get the tension in the upper chord using the tension for the bucket, Mg and also Ma.